Hello everyone! This video is the part 2 of the video series under this topic, sampling distribution of the sample mean x bar. And the focus of this video is about probability for the sample mean x bar. Our goal is to be able to calculate the probability for certain values of the sample mean x bar. And by calculating the probability of certain values of x bar in a repeated sampling, we can describe the behavior of the sample mean x bar, whether that particular value of x bar is likely to happen or unlikely to happen. Note that the process described in this video is only applicable if the distribution of the sample mean x bar is either normally distributed or approximately normal. And just to remind everybody, the sampling distribution of the sample mean x bar is normally distributed if the sample is taken from a population that is normally distributed. And the sampling distribution of the sample mean x bar is approximately normal if the sample size is 30 or more, regardless of the distribution of the population. Here are the steps for calculating the probability of the sample mean x bar. First, write down the event of interest in terms of x bar. Second, convert the necessary values of x bar to z values using the formula z equals x bar minus mu divided by the standard error of x bar. Third, use the normal curve table from your textbook or using the normal CDF function of your TI calculator to determine the appropriate area under the normal curve. Now let's take a look at some examples. Here is example 1. Suppose a random sample of n equals 25 observations is selected from a population that is normally distributed with mean of 105 and standard deviation of 10. Question A. What is the probability that the sample mean x bar exceeds 110? Question B. What is the probability that the sample mean x bar is between 100 and 108? So in this question, we are told that the population is normally distributed. So that means that the sampling distribution of the sample mean x bar is also normally distributed. And we are also told that the population mean mu is 105 and the standard deviation of the population sigma is 10. So now for question A, we are asked to determine the probability that the sample mean exceeds 110. So we can write the probability question P of x bar greater than 110. And from this, we can calculate the z value corresponding to x bar 110. And our formula is z equals x bar minus mu over the standard error of x bar. The standard error of x bar is given by this formula, sigma divided by the square root of n. Our sigma is 10, our n is 25, so we have here 10 over square root of 25. Our standard error of x bar is 10 over 5 or equal to 2. So now going back to the z formula, z is equal to x bar minus mu over the standard error of x bar. We replace x bar with 110 and we replace mu with 105 and we replace the standard error of x bar with 2. So we have z equals 2.5. Once we have the z value, we draw the normal curve. And in the middle of this curve is 0. And on the right side of 0 is the z value 2.5. And because the question is asking for the probability that x bar is greater than 110, so we want to find the area of this shaded portion under the curve from z equals 2.5 to infinity or E99. And this is how we use our TI calculator in finding the area under this normal curve from z equals 2.5 to infinity or E99. We use the secant function distribution and then select the second option, normal CDF, and then we press 2.5, comma, and then E99, and press enter, and that gives us the value 0.0062, with 4 decimal places. And that means that the probability that x bar exceeds 110 is equal to 0.0062. Now for question B, we are asked to determine the probability that the sample mean x bar is between 100 and 108. So we set up the probability question in terms of x bar. So we have here probability that x bar is between 100 and 108. And then we are going to calculate the z value corresponding to x bar equals 100, and we'll call this z value z1. And also we are going to calculate the z value corresponding to x bar equals 108, and we'll call this z value z2. For z1, we have x bar minus mu over the standard error of x bar. Z1 is equal to 100 minus 105 over 2, and this gives us Z1 equals negative 2.5. For Z2, we have here Z2 equals x bar minus mu over the standard error of x bar. Z2 equals 108 minus 105 over 2, and this gives us Z2 equals 1.5. Now that we have the values of Z1 and Z2, we are now ready to draw the normal curve and locate this Z1 and Z2. Now we have here the normal curve, and we have located the Z1. Z1 is equal to negative 2.5 and Z2 equals 1.5. And because we want to find the value of the probability that x bar is between 100 and 108, we want to find the area under the normal curve between Z1 equals negative 2.5 and Z2 equals 1.5. And using our TI calculator, normal CDF negative 2.5 to 1.5, and this area is equal to 0.9270. So therefore, the probability that the sample mean x bar is between 100 and 108 is equal to 0.9270. Let's consider now example number 2. A certain type of automobile battery is known to last an average of 1,110 days with a standard deviation of 80 days. If 400 of these batteries are selected, determine the following probabilities. Question A. That the average life of the selected batteries is greater than 1,115 days. Question B. That the average life of the selected batteries is between 1,100 and 1,115 days. Note that in this problem, we are not told about the distribution of the average life of the batteries. But what we know is that in each sampling, there are 400 batteries used. And because our n in this case is greater than 30, then we know that the sampling distribution of the average life of batteries is approximately normal. And we can use the process that I described earlier. For question A, we are asked to determine the probability that the average life of the batteries is greater than 1,115 days. So we set up the probability question in terms of x bar. So we have here probability that x bar is greater than 1,115. And then we will convert this x bar value into z, and our formula is z equals x bar minus mu divided by the standard error of x bar. Now, our standard error of x bar is equal to sigma over square root of n, and sigma, the standard deviation of the population, is equal to 80, and our n is 400. So 80 divided by square root of 400 will give us 4. So the standard error of x bar is equal to 4. And going back to z, we have z equals x bar minus mu divided by the standard error of x bar. And by substituting the values, z is equal to 1,115 minus 1,110 divided by 4, and this gives us z equals 1.25. Now that we have the z value, we can draw the normal curve and then locate the z value 1.25, and because we want to find the probability that x bar is greater than 1,115, we're looking for the area from z equals 1.25 to infinity or to E99. Now using our calculator, secant function distribution, normal CDF from 1.25 to E99. And we have here 0.1056. Using 4 decimal places, the probability that the sample mean is greater than 1,115 days is equal to 0.1056. Now for question B, we want to determine the probability that the average life of the batteries is between 1,100 and 1,115 days. So we can set up the probability question in terms of X bar. Probability that X bar is between 1,100 and 1,115. So we are going to solve for Z1 corresponding to X bar equals 1,100. And we will also calculate Z2 corresponding to the X bar value 1115. So our Z1 is equal to X bar minus mu over the standard error of X bar. And by substituting the values, we have Z1 equals 1100 minus 1110 divided by 4. And this gives us Z1 equals negative 2.5. Now for Z2, this is equal to X bar minus mu divided by the standard error of X bar. And by substituting the values, Z2 is equal to 1115 minus 1110 divided by 4. And this gives us Z2 equals 1.25. Now that we have the Z value, we can draw the normal curve and locate Z1 negative 2.5 and Z2 positive 1.25. And to find this area, we will use normal CDF from negative 2.5 to 1.25. And this gives us the area of 0.8881. So therefore, the probability that the sample mean X bar is between 1,100 to 1,115 days is equal to 0.8881. Okay, that's all for today. Until next time, thank you for watching.